You are standing at the edge of a river. On the other side, food, safety, your family's next camp. You cannot swim that far. You cannot hold your breath long enough. Your legs, the most advanced walking machine evolution ever built, are suddenly useless. And then, one day, you watch a dead tree drift past on the current, and something in your head clicks. So how does a land animal with no gills, no fins, and no instinct for open water end up crossing entire oceans? The answer starts on an island that should have been impossible to reach. On Flores in modern Indonesia, archaeologists have pulled stone tools out of the ground that date back roughly 1 million years. Not 1,000, not 10,000, 1 million. And here's the detail that breaks the story open. Flores has never been connected to the Asian mainland. Not during any ice age. Not at any point in the last several million years. To get there, something crossed at least 12 kilometers of open, current-swept water. The species that left those tools was not us. It was likely Homo erectus, a smaller-brained relative that came before Homo sapiens even existed. We have no wood, no rope, no wreckage from whatever they used. Wood rots. Rope disintegrates. All that survived is the proof that something worked. That is the entire problem with this story. Boats do not fossilize. Stone tools last 1 million years. A raft lasts maybe a decade before it is gone completely. So almost everything we know about the first boats has to be reconstructed backward from the fact that people kept showing up in places they should not have been able to reach on foot. Which brings us back to the log. Somebody, somewhere, watched enough dead trees drift past on a current to notice a pattern. Heavy things sink. Wood does not. That single observation, repeated across thousands of generations, is the seed of every ship that has ever existed. But noticing that wood floats and controlling a floating log are two completely different problems. A tree trunk is round. Climb on top, and your weight sits high above the center of the log. And the log rolls. It dumps you straight back into the water you were trying to escape. Early attempts to ride a log were probably violent, clumsy, and short. The log solved one problem and immediately created another. So the next leap was not a new material. It was a new shape. If a solid log rolls because your weight sits on top of it, the fix is to move your weight inside it instead. Hollow it out, and the center of gravity drops low enough that the vessel stops fighting you. Early builders did this with stone tools alone, scraping wood fiber by fiber, which took days of brutal effort. Then someone figured out a shortcut. Fire chars wood in minutes. Charred wood scrapes away easily. Burn a little, scrape it out. Burn again, scrape again. And a log that would have taken a week to hollow by hand could be finished in a few days. This exact fire and scrape method shows up independently on nearly every continent, in cultures that never had any contact with each other. That is not a coincidence. It is what happens when the same physical problem meets the same limited set of tools again and again across the planet. The oldest confirmed boat we have ever pulled out of the ground used exactly this technique. It was found in the Netherlands in 1955 during roadwork, and it very nearly got thrown away as a rotten log before someone recognized what it actually was. Carbon dating placed it at roughly 10,000 years old, 3 meters long, a single hollowed pine trunk, small, plain, easy to miss, and also the oldest physical proof we have that humans were not just clinging to driftwood, they were already engineering it. But a hollowed log has a hard ceiling. Your boat can only ever be as wide as the tree it came from, and a narrow boat with a low ceiling on size is never going to carry a family, let alone cross an ocean. Which is exactly the wall that stood between a river crossing and something much bigger. Because 65,000 years ago, modern humans reached the continent we now call Australia. We know this from a rock shelter called Madjedbebe in the Northern Territory, where archaeologist Chris Clarkson and his team recovered thousands of artifacts from a layer old enough to push the accepted date of human arrival back by roughly 18,000 years. Here is what makes that arrival almost hard to process. Even at the lowest sea levels of any ice age, Australia was never connected to Southeast Asia by land. Not once. To get there required crossing at minimum 60 to 90 kilometers of open water, out of sight of any coastline, with no way to know for certain that land existed on the other side at all. No metal. No sails. No instruments. No written language to pass instructions down. And still, an entire continent got populated because whatever vessel carried those first travelers held together long enough and carried enough people to found a population that has never stopped since. A single log could never have done that. A vessel built for that crossing had to carry supplies, several adults, and enough of a founding group to survive on the other side. That is not a lucky raft ride. That is a planned voyage using a real, deliberately built craft, 65,000 years before anyone would think to write anything down. The next wall was the open ocean itself, and the fix for it was not a bigger log. It was a completely different idea about what a hull even needed to be. Somewhere around 5,000 years ago, on the island we now call Taiwan, a group of people began spreading outward in a migration that would eventually cover a third of the surface of the planet, entirely by boat. What let them do it was a single design choice. Take a narrow, fast hull and attach a second float to one side using a pair of crossbeams. A narrow hull alone is fast but tips easily. A wide hull is stable but slow and heavy to paddle. The floating outrigger solves both problems at once without solving either one by simply making the boat bigger. It let a canoe carry a family, seeds, animals, and drinking water across open water for days at a time without capsizing. And the navigation that went with it was not guesswork. Sailors read the angle of starlight, the shape of ocean swells bending around islands they could not yet see, and the flight patterns of birds that only ever ranged a fixed distance from land. None of it was written down. All of it was carried in memory, tested against real voyages and passed from one navigator to the next. On the other side of the world, a different problem produced a different answer. Egyptian shipbuilders did not have long, straight trees to carve into a single hull. What they had was short, twisted acacia wood, and a river that demanded something bigger than any log could provide. So they stopped trying to carve one tree into a boat and started fitting many separate planks together, edge to edge, into a hull no single trunk could ever have matched. A vessel built this way could be far larger than anything a dugout allowed. And once shipbuilders were no longer limited by the size of one tree, the ceiling on how big a boat could be effectively disappeared. None of those steps happened because of one flash of genius. Each one was the same instinct, applied again and again. Watch what floats. Test it, fail, adjust it, teach it to the next person. That is not a lesser version of engineering. That is engineering, running at the slowest possible speed across the longest possible span of time. And none of it was ever a solo achievement, even when the archaeological record only leaves us a single boat to look at. Felling a tree without metal tools takes coordinated effort. Hollowing it takes days someone has to be fed and sheltered through. Knowing which timber resists splitting, which coastline is safe to launch from, which season brings calm water, is knowledge that has to be tested, survive being wrong at least once, and get passed on before it can ever become tradition. A canoe that worked was never really the product of one clever builder. It was the product of a group of people who kept trying, kept failing in slightly smaller ways each time, and kept teaching whatever they had learned to whoever came next. That is the part the surviving wood can never show you. The log or the plank you find in a museum case is just the last visible link in a chain of trial and error that stretched back for generations before it. Look at the full distance covered. 1,000,000 years ago, something with a brain 2/3 the size of yours drifted or paddled across 12 kilometers of open ocean using nothing we would recognize as a boat. 65,000 years ago, a species exactly as intelligent as you are crossed nearly 90 kilometers of open water on purpose in vessels built to carry a founding population, not just one lucky traveler. 10,000 years ago, someone in a cold, marshy corner of Europe carved a pine log into a hollow shell using fire and stone, because without it, the flooded ground around them was simply unusable. 5,000 years ago, a stabilized hull design let one culture colonize a third of the planet. And somewhere in between, a civilization without proper timber figured out how to build boats bigger than any single tree by refusing to accept that limitation at all. Every one of those steps solved the exact problem the previous version had created, and every one of them left the next generation with a slightly harder ceiling to push past. Right now, tonight, there are tens of thousands of ships moving across the same oceans that swallowed every trace of the first boats ever built. Satellites track them. Engines the size of buildings push them forward. None of that changes the basic physics underneath the hull. Something floats. You climb on. You figure out the rest on the way.